First, let's be clear. Kelly's CueBillet program is not meant to replace your CAD/CAM program. Instead, it's a supplement that will allow you to do many common tasks without ever leaving your CNC machine. You don't have to draw anything. Let me repeat that. You don't have to draw anything. You simply enter some basic numbers to define the sizes you want, and CueBillet generates a program based on that. Manually cutting the thickness of a slab is no big deal. Everybody watching this can manually jog a cutter over the slab and eyeball the overlap. If it doesn't clean up, you incrementally jog down a 30-second or so and try it again. When one side is finished, you flip it over and wing it again. This works great until you accidentally wrap it down in Z instead of stepping down. Talk about a wake-up call. CueBillet allows you to enter the width and length of your slab, and there's nothing fussy here either. Tell it how much you want to take off, your cutter size, your feed rate, and that's it. You have an idiot-proof program. Cutting strips for use in a ring billet isn't a big deal either. Once your slab is the correct thickness, you can bandsaw them to whatever size you need, depending on the depth of the slots in your billet. But first you have to do some basic calculating to make sure that you'll get all the strips you need out of the slab you have. I generally draw it up and tweak the sizes to make sure everything fits, and since I already have it drawn, I generate a program to machine the strips. I know it's not necessary to machine them, but once you do it, you get spoiled, and you'll never cut them on a bandsaw again. Again, CueBillet makes it easy. You just enter the slab size, how wide to make the strips, and how deep to cut. Not only does it instantly spit out the number of strips you'll get out of the slab, it gives you a visual representation of the slab with the strips cut in it. If you need more strips, make them a bit narrower or use a smaller cutter. You don't have to draw anything. Just enter the numbers and your program is ready to load. I think it'll help if I walk you through cutting a slab to thickness and then cutting the strips from the slab. So let's get started. Okay, here I have a slab of curly maple that measures roughly 2 inches by 6 inches. I need strips that are 175 thou thick. This slab was cut on a bandsaw and measures roughly 280 thousandths thick. That makes it about 110 thousandths thicker than what I need, and it'll have to be cut down. So let's open CueBillet and I'll give you a quick rundown on the initial setup. Once you establish some defaults on the job, it'll go quicker on successive jobs. As you can see, you have pages for slabs, strips, joint billets, A-joint billets, and butt billets. We're doing slabs first, so we'll go back to that page. The first thing you'll do is decide how you want to orient your slab and where to put 0, 0. By clicking on the icon here, you can move the red corner wherever you want it. I like to put it in the upper right corner, and as you can see, the corner X and Y positions will be designated 0, 0. Safe Z by default is 1 inch above your piece, and Z top of stock is set at 0. Now I can enter my slab width, which is 2 inches, and the slab length, which is 6 inches. Since I need to remove just over 100 thousandths, I'll enter a depth of cut of half that, or 50 thousandths for this side. My cutter diameter is 1 inch, and a step over percentage of 75% is fine. Now, for number of passes, 1 would probably be fine, but I'll just do it in 1 cut and take a light finish pass. It's a fairly light cut. So I'll boost the feed rate quite a bit and lower the final cut to 3 thousandths. And that's about it. I can generate the G code now and it's ready to run. First I see something that needs attention. The red lettering shows that I made the upper right corner 0, 0. Resetting the defaults will remove the red and eliminate the need to fuss with this whole left column in the future. Okay, let me look everything over once more and create the G code. I've already established where it will be saved, so it's all pretty standard. Now I can load the program into Mock. Again, it's pretty basic. I can check out the preview, and it's about what I expect to see. If I zoom into the start of the cut, you can see how the cutter rapids down to Z0, then moves off of the slab, and then feeds down to the depth of cut. From there it follows the pattern needed to clean up the surface. And the program limits all look good. Time to let her rip. I'll hurry this up in case you have better ways to waste your time. Since this slab is now 50 thousandths thinner than when we started, we need to reset the Z setting in Mach. I'll just change the Z setting from 1 inch to 1 inch 050. This compensates for the material we removed, and we're all set for the cut on the other side. Now I have to check the thickness of the slab so I know how much to remove from the other side. It looks like it's about 230 thou thick now, so that means I have to remove another 55 to get to my target of 175. Back in CueBillet, all I really need to do is change the depth of cut to 55 thousandths, since that's what will get me down to 175. I'm looking over everything else here because this is still new to me too, but it looks like I'm good to go and can create the new G code. Close out the original program first, then create the G code. And I'll zip through the second side cutting because, well, you know, you have better ways to waste your time. Now that the slab is at the correct thickness, I'll be switching over from slab cutting to strip cutting. I have to change the X width and Y length. And I'll remove the buffer, though it probably won't matter with this job. And the strip X length. This depends on the depth of the slots in your billet. I'll go with 150 to start. And I'll make the strip Y length 2 3/4 inches. The cut depth is the actual thickness of the slab, and this is the target width of the ring billet slots. If you recall, that was 175. Cutter diameter is okay. And you can see here what the visualization shows. Let me tweak a few settings to see how it changes things. Changing the perimeter buffer doesn't make much difference with my other settings. And I'll make the strip width larger since it won't hurt to have the strips taller than the billet slots. You can see how it shows that I will end up with 16 strips. What the heck, I'll make the strips even taller. And going 175 thousandths deep means I should probably do this in 2 cuts. And I'll make the final Z pass a bit heavier. Bear with me as I look this over. This is new to me too, but it looks good. After loading the program in Mach, I'll look it over on the preview screen and check the limits. And it all looks okay. I'm just marking the top surface so I know how the strips were oriented. And we're cutting strips. Checking the size shows me that we have 180 by 175, just like we planned.